All right, so this video goes through product rule. So this is a shortcut technique for taking derivatives. This is one of three of the main types of rules you're going to see a lot: product rule, chain rule, and quotient rule. It's something you're going to be introduced in whatever your first calculus class is. And I think it's one of the easier rules to kind of get memorized. All right? So here is what product rule states. Say you have some function, h of x, and you can write it as a combination of one function multiplied by some second function, f of x times g of x. The product rule says if you want to take the derivative of h of x, well, that's going to equal the derivative of your first function multiplied by the original second function here, added to the original first function multiplied by the derivative of the second function. And I think this, going through examples, especially with product rule, helps you understand what's really going on here. So just to start out, I have a pretty simple example here, and I'm going to kind of write out specific steps that, especially if you're just starting to learn what the product rule is, I suggest this is kind of how you approach each problem. Okay, so we have this function, h of x, and then in the first set of parentheses, 3x squared minus 1. And then in the second set of parentheses, x to the third plus 4. And we want to find the derivative of that. Okay, so to the side, I'm going to write out four things, right? I'm going to write out f of x here, and that's equal to something, f prime of x, or the derivative of f of x, and then g of x and g prime of x. And I'm going to use this to help me keep track of everything going on in the problem, right? In order to use product rule, I need f here, I need f prime there, I need g, and I need g prime. So I'm going to use this as kind of like a way of organizing my information. So what is f of x? Well, let's see how we can break this apart. For product rule, it should be pretty straightforward. It's whenever you have some term that has the x in it, that has your variable, multiplied by some other term with your variable. So I'm going to make this our f of x, while I make this thing our g of x. So f of x is going to be, right here, 3x squared minus 1, and g of x is x to the third plus 4. Now let's figure out what each of these are, derivative of f and derivative of g. So from now, you should be, at this point, you should be familiar with the power rule. So taking the derivative of 3x to the second minus 1 should be pretty easy. Very quickly, we'll get that the derivative is 6x. Okay? Similarly, the derivative of x to the third plus 4 should eventually just get you 3x to the second as your derivative. Now that we have all the individual parts that we want, let's go about putting this together. Okay? So using our product rule, let's write this out. I know h prime of x should equal the derivative of the first thing, which I made f of x, times the original second thing, which the original second thing was g of x, plus the original first thing, times the derivative of the second thing. And now I can just take each of these and plug them in. So derivative of f of x is 6x. The original g of x term is right here, x to the third plus 4. And now we add it to the original f of x, which is 3x squared minus 1, and multiplied by our g prime of x, which is 3x to the second. So this was mainly to demonstrate how kind of writing this legend, you could say, on the side is there in order to help you more easily take derivatives using the product rule. All right, and then at this point, you've actually done the calculus. Now you have to do the algebra of multiplying everything out. So let's just finish that off, right? So 6x gets distributed here and here. 6x times x to the third is 6x to the fourth. 6x times 4 is 24x plus, and then here the 3x squared can be distributed. Okay, so 3x squared times 3x squared, that's just 9x to the fourth. And then 3x squared times -1 is minus 3x squared. And then this can be further simplified, and that gets us 15x to the fourth minus 3x squared plus 24. And now we have our final answer, our derivative. Right? So a lot of people don't necessarily do this. At a certain point, you might just get, hopefully, you'll get good enough where this isn't necessary. But even if you are at the point where you're an expert in this, you still might like just keeping things organized in the corner. All right, so now let's move on to some harder examples. All right, so here I have the function f of x, and that is in the first set of parentheses, x to the fourth plus 3, and then multiplied by the second set of parentheses is negative 4x to the fifth plus 5x to the fourth plus 5. Now notice I don't have it, actually my function isn't h of x. That really doesn't matter that much, it's just notation. So I can just pick any functions to be, these two things. So I'll use the method, that chart method I kind of did from the last example. Okay, so first let's figure out what my first function is and what my second function is. Since I'm already using f of x here, I'm going to use g of x and h of x to be my other two functions, to be the parts. So I think it's, again, with product rule, pretty clear to see what is multiplying what else. So I can use this to be g of x, and this function here can be h of x. And then off here, I'll just do g of x, g prime of x, h of x, h prime of x. All right. Now let's start filling these in. So g of x I've listed as x to the fourth plus 3, while h of x is negative 4x to the fifth plus 5x to the fourth plus 5. Now let's go about finding the derivatives of those. All right. Again, these just use power rule. You should be fairly familiar with that. So x to the fourth plus 3 gets you 4x to the third. And then derivative of this function, negative 4x to the fifth plus 5x to the fourth plus 5, should get you negative 20x to the fourth plus 20x to the third. All right, now we have all the parts we need. So what is f prime of x? Well, that should be, if we split it up into two different functions using product rule, it should be the derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. And then you just fill in the gaps, right? G of x, or g prime of x, sorry, is just 4x to the third. The original h of x function I have right there, negative 4x to the fifth plus 5x to the fourth plus 5. I didn't leave myself enough room here, so I'm just going to put the addition sign down there. And now my original g of x function is x to the fourth plus 3 multiplied by my h prime of x, which is negative 20x to the fourth plus 20 plus x to the third. Okay? Negative 20x to the fourth plus 20x to the third. And at this point, we can start multiplying these out. Okay? So distributing the 4x to the third, right? At this point, the calculus is done. Now we have to do the algebraic stuff. So 20x to the third times negative 4x to the fifth. That should get us negative 16x to the ninth. So down here, negative 16x to the ninth. 4x to the third times the 5x to the fourth. Oh, sorry, should be to the eighth, not to the ninth. 4x to the third times 5x to the fourth just gets us plus 20x to the seventh. And let's see, what else? 4x to the third times 5 will get you just 20x to the third. So plus 20x to the third. So now we've done this half. We have to go about doing this half. Okay, so again, you should be used to distributing. X to the fourth times negative 20x to the fourth should be, just in parentheses, negative 20x to the eighth, x to the fourth, and positive 20x to the third, positive 20x to the seventh. And let's see what else. The x to the fourth, and, oh sorry, we're done with the x to the fourth. Positive 3, negative 20x to the fourth is minus 60x to the fourth, and then positive 3, positive 20x to the third is positive 60x to the third. Now from here, we can start combining like terms. Okay, so let's check off everything with an eighth to it. So that's the negative 20 and the negative 16. That should get us negative 36. So negative 36 x to the eighth. Next is anything with the seventh power. So that's going to be our positive 20 here and our positive 20 here. Right? And I skipped the step of opening up the parentheses because everything would have stayed remotely the same because this is a positive up front. So combining our negative 20 and our other negative, combining our positive 20 and our other positive 20 will just get us positive 40x to the seventh. And everything to the, the fourth power. There's only one item, so that'll just stay negative 60x to the fourth. And the very last thing, our positive 20 to the third here, and our positive 60x to the third there. That finally gets us positive 80x to the third, and that's your final answer. All right, so honestly, the thing that takes the longest is just the algebra, something you should be very familiar with at this point. Okay, let's move on to a different example. All right, so this next example, a little more complicated, but still same product rule we're using. We have here the third root of x squared multiplied by, and then in parentheses, 2x minus x squared. All right, so first let's identify what are our two functions we're multiplying together. The first function will be right here. this third root x squared, and I'll make that g of x. And the second function we're using, right here, this 2x minus x squared, I'll make h of x. Now I'm still going to do the chart to the side, and at a certain point, you know, all of you will eventually become experts in this, and you might not need to actually write this to the side, although you still might prefer to, right? This isn't necessarily just something you do when you're practicing. If you find it helps you keep track, then go for it. Use this kind of trick. So our third root x squared is our g of x, and we need to find g prime x, right? That's the first thing, and we need to find the derivative of the first thing. Our second thing, h of x, is 2x minus x squared, and we need to find h prime of x. So this third root, x squared, a little bit harder to take the derivative of, but still uses the power rule, okay? So to use power rule, we want to convert this into something easier to differentiate, and I'm going to convert this to a fractional exponent. You should be familiar with this already, but when you have a root, you can change it into an exponent where whatever root you're taking, so this is the third root, for example, that goes into the denominator of the fraction. So this is the same thing as x to the 2 over 3, all right? And like I said, this should be straightforward, very easy, something you should be very familiar with. So let's go about taking the derivative of each of these. Using the power rule, we find the derivative of g of x is actually 2 over 3 x raised to the negative 1 over 3. And then we find the derivative of 2x minus x squared is just 2 minus 2x. And easy, we have all the components we need to actually take the derivative. So let's go ahead and do that. The derivative of f of x, and our parts are g of x and h of x, so that's going to be the derivative of the first thing multiplied by the second thing, plus the derivative of the second thing times the first thing, right? So g of x times h prime of x. And now we're going to substitute. Very simply, that's going to be x to the derivative of the first thing, 2 over 3 x raised to the negative 1 over 3 multiplied by the original first thing, 2x minus x squared, plus the original first thing, so that's going to be x raised to the 2 over 3 multiplied by the derivative, 2 minus 2x. Now, at this point, you should be tired of the phrase, calculus is done, now it's time for the algebra. I say it a lot, not just to be annoying, part of it's to be annoying, of course, but knowing algebra, super important for calculus. This part's, I find, easier than this next part of multiplying this out. Multiplying out is actually very annoying. I don't want to do it, but I mean, if I'm going to make a video, I might as well just do it all the way. So multiplying this out here gets us 4 over 3 as our coefficient. X raised to, now the exponents obviously get added, and we're going to get 2 over 3 as our exponent. And that's going to be now subtracted by 2 over 3 x to the 5/3. And here I distribute that as well. And that's just going to be added to 2x to the 2 over 3 minus 2x to the 5 over 3. Now I can start simplifying. I look for common exponents. And what you do is you combine the 4 over 3 x to the 2 over 3 and the 2x to the 2 over 3. And you'll end up with 10 over 3 x to the 2 over 3. And then same thing, you combine these two components that both have the exponent as 5 over 3. And you'll just get minus 8 over 3 raised to x raised to the 5 over 3. Now, depending on what your professor or your teacher might ask you for, you might need to make sure you aren't left with fractional exponents. Typically, real-world kind of stuff, it's fine. It depends on what you're kind of working on and what your preferences are. But let me just convert them back, depending on what form your particular instructor wants you to leave it in. So obviously, this denominator becomes the new root. So this becomes the third root of x to the second minus your coefficient of 8 over 3 stays the same. And this becomes the third root of x to the fifth. And that would be your final answer. If your particular professor or teacher doesn't require you to leave it in this form, I would suggest leaving it in this form. For the purposes of an exam, do the least amount of steps, right? The least amount of steps you do, the less likely you are to make a mistake, the less chances you have to actually make a mistake. And that'll, hopefully get you a higher score. All right, so let's try a slightly harder example. All right, so this is one example I wanted to make sure I go through. Okay, so we have these items being multiplied together. F of x is our original function, and that's equal to, the first set of parentheses says x cubed plus 2. The next set, 3x squared plus x. And a third set of parentheses, 4x to the 8th minus 2x squared. So you might be thinking, what do we do when we have 3 items being multiplied? Is there some version of the product rule where we do it 3 times? Kind of, right? Sorta. Not exactly, but that's close. So what we're doing is we're going to do the product rule multiple times. So product rule still stands. We still have stuff being multiplied, but I'm going to group a few of the things together. Okay? And here's how I'm going to do it. It looks like the way I want to group it, I'm going to group this stuff, all of it, to be h of x. Sorry, g of x, actually, just for. And all this stuff is going to be h of x. Now, let's start by just making our chart. Like I said before, if you're used to not using it at this point, perfectly fine. This is just for kind of instructional purposes. So we know what our g of x is, and that is x cubed plus 2 and 3x squared plus x. While our h of x, and let me just write the g of x here. Trying to figure out what that is. I'm going to leave a suspicious amount of room underneath. And h of x is equal to 4x to the 8th minus 2x squared, and we need to figure out what h prime of x is. Now I'm going to leave this to be the second derivative we do, because it's easier to look at the h prime x and figure that out. Okay, that's just a derivative you're familiar with doing at this point, power rule. We end up with 32x to the third, and subtracted by 4x. Now for this derivative of g. Okay, the way we're going to go about it is, take it as a normal derivative. And since we have two things being multiplied to each other, we have a rule of taking care of that. It's the power rule. So this is kind of like a power rule inside of another power rule, like Inception. I'm pretty sure that movie was about calculus, or maybe it wasn't. I don't know. So let's split this up into two components, right? Let's say we'll use j of x and k of x, okay? So this first part, I'll make a k of x, and the second part, I'll make a j of x. So this g of x component needs to have product rule done on it before we can use it in the full function, okay? So let's figure this out. K of x, we know to be x to the third plus 2. K prime of x, taking the derivative, we'll find that to be 3x. Just 3x to the second. That's it. And just 3x to the second. J of x, we know is 3x squared plus x. And taking the derivative of that, j prime of x is equal to 6x plus 1. Now let's put that into our original function. So we know g prime of x should be, I'll write it over here because I didn't leave myself enough room here, g prime of x is equal to the derivative of the first thing here. So that's going to be 3x squared times the original second thing right there. That's 3x squared plus x plus the first thing, x cubed plus 2, times the derivative of the second thing. And we figured that to be 6x plus 1. All right? Now we need to simplify this. So for this first part, just multiplying it out, right? This should get us 3x squared times 3x squared is 9x to the fourth. And that's added with 3x to the third. Now we have to multiply out this second half of the equation. So multiplying this out will get us 3x to the third and 6x should get us 6x to the fourth. 3x to the third and 1 should get us plus 3x. 2 and 6x should get us plus, this should be 3x to the third. This should just be x to the third. My bad. No 3 there. Right, and then what was next? 2 times 6x is 12x. And then 2 times 1 is 1. And now we can combine like terms. The 6x to the fourth and the 9x to the fourth can combine, 15x to the fourth. The x to the third and 3x to the third, that combines to become plus 4x to the third. And we have a plus 12x plus 1. Now we can go back to our original function, okay? So keep in mind, here's our original g of x, here is our g prime, here's our original h of x, here's our h prime, okay? So although these are definitely messier to do, Still doable as long as you keep track of all the information you have. So, f prime of x. Well, that's going to be the derivative of the first thing, which is right here, right? 15x to the fourth plus 4x to the third plus 12x plus 1 times the first thing, or times the second thing, which is 4x to the eighth minus 2x to the second plus the original first thing, which is x to the third plus 2 times 3x to the second plus x multiplied by the derivative of the second thing, which I'll write down below, right? So that this continues down here. 32x to the third minus 4x. All right, let me just get a separate sheet of paper. All right, I got one here. And simply for just, the fact that multiplying all of this out would take a little bit of time, I'm just going to write the final answer. Typically, you would be able to, if I were grading something, I would allow you to leave it in this form, and that would be your final answer. If your professor or teacher would want you to multiply all of this out, good luck, because goddamn do they suck. Like, that would just be awful. But here's just the final answer. It's simple to multiply out, but really, really annoying. So f prime of x should end up equaling 60x, already miswrote, 60x to the 12th plus 16x to the 11th plus 48x to the 9th plus 100x to the 8th plus 32x to the 7th minus 42x to the 6th plus 180x to the 5th plus 64x to the 4th minus 48x to the 3rd minus 10x to the 2nd. And that would be your final answer for that one if you're required to multiply all that out. Hopefully you wouldn't be. So just to review, here's our original sheet I had out. For product rule, right? It's used whenever you have a function that can be represented by one function multiplied by another, and it helps you take a derivative a lot quicker than using definition of a derivative. Now, this legend here to the side definitely helps out, especially when you're starting out. If you find you kind of like it, keep doing it, right? It's all about personal preference at that point. Other than that, main things to keep in mind is just make sure to correctly label what your functions are, what the individual parts are. Keep track of which point you're using them. You don't want to accidentally do f prime times g prime plus f times g, right? Or any mix-up like that, where even if you had all the derivatives done correctly, you still would, get the answer wrong because of that. And also just make sure you just do your algebra really clean. Other than that, that kind of sums it up. Hopefully, maybe you might have to watch this back a few times, but hopefully you're, at this point, an expert in the product rule. If you have any questions, throw it down in the comments, but good luck. Happy painting.